Okay, so we're going to go over the remainder theorem. So the remainder theorem states that if polynomial f of x is divided by x minus k, then the remainders are the value f of k. So first of all, let's kind of digest what this kind of means, right? So in the previous section, we went over the division algorithm here for our polynomials. We had the divisor multiplied by the quotient times plus the remainder, and that's how we could represent the polynomial, right? Once we do our long division or our synthetic division. All right. Now we're gonna focus here in this chapter. Essentially, the goal would be to find all the polynomials zeros, right? And one of the ways to do that, we're going to be looking for these linear factors, right? So our divisor is going to be of this form. X minus k. All right. Okay, so it's a linear divisor. So another thing that kind of tells us is if we're doing synthetic division, the remainder is always 1 degree less than whatever the divisor is going to be. Right. So if the divisor is linear, the remainder is just going to be a constant term. Right. So if we have here the divisor is x minus k plus r, right? Where r in this case is going to be some real value. All right, so not some function of x. And if we plug in the value of k, what we see here, oh, forgot the q of x here. What happens here is that this goes to 0, and we're simply left with the remainder, right? Which can be found quite easily actually using synthetic division. Right, now what does that mean? What does that allow us to do? Right, it's a very nice result here, which means that if for example, let's say I wanted to find, let's just say evaluate f of x equals 2x to the 5th minus 3x to the 4th minus 9x cubed plus 8x squared plus 2 and x equals to negative 3. All right. So now before we would take negative 3 and we plug it in wherever we see an x, raise it to the 5th, raise it to the 4th power, do all these algebraic operations. But this remainder theorem actually is quite nice because now it allows me to do this by finding the remainder of the polynomial division. Right? In this case, the division, since we can interpret this as x minus 3, excuse me. Okay, so the way that I can do that here, in this case, we can say f set up a long division, right, where I'm going to plug in negative 3, right, or excuse me, not a long division, synthetic division, and take the coefficients, 2, negative 3, negative 9, 8. There's no linear term, x, so make sure to have a 0 there, and then 2 for the constant term. All right, and now evaluating this is as easy as just bringing down the 2, negative 6, negative 9, 27. Here we have, what is this, 18, 4, 54, and this becomes 46. So this becomes 18, 12, 13, 0, 38 times negative 3, and here we get negative 11. Okay, and we get 460. Right, so that is our remainder, but that is also f of negative 3, the evaluation at that point. Okay, so notice here that this is a much more straightforward operation than what we had before. And Actually here, I forgot a negative here. So this is 412. Negative 412. All right. Okay. And that's how you would apply the remainder theorem here to evaluate at some value for x.